Hello everyone, and welcome. Welcome to tonight's stream. Alright, we are doing Algebra and Trigonometry. It is part of the OpenStax initiative of Rice University. It is in the Creative Commons, so download the book. It's in the video description. It's free. I have a physical copy of the book. It's very nice. And now we are continuing from where I left off yesterday. We did the reading yesterday with examples, and now we're going to do the chapter questions 1.5, and we are doing the odds. The odds have answers in the back of the book, so if you want, you can download the book and you'll actually know if I'm getting it right or wrong before I do. So let's get right into it. Okay, by the way, just so you know, this book goes to 1.6 and then we go into 2. All right, that's pretty cool. All right, we have 1.5, verbal. If the terms polynomial do not have a greatest common factor, does that mean that it is not factorable? Okay, so if the polynomial does not have a greatest common factor, let's write this down. So this is my answer. I say false. If the terms of a polynomial do not have a greatest common factor, does it mean it is not factorable? Question mark. I say false. Consider, let's go a squared minus b squared, which can be factored as a plus b and a minus b, right? Which is equal to a times a is a squared, and then we say minus ab, and then minus or plus ab, and then minus b squared. So as you can see, and it is in fact factorable. So this is the factoring of it. And so I just did a counter example. Let's take a look at what the book says. And that was just one of the formula that we've been working with. So yeah, that's just a common one to remember. That's the difference of squares formula. Alright. Alright, odd answers, section 1 point. The terms of a polynomial do not have to have a common factor for the entire polynomial to be factorable. For example, 4x... Oh, so just did a... that's fine. Yeah, they did also a difference of squares. Let's do theirs real quick. So they did the 4x squared. This is the book's example, minus 9y squared, right? So that's also a difference of squares, just as I did right here. And using my formula here, the formula, we can say we know that it is a square root 4x is equal to 2x, and the square root of 9y is equal to 3y, y squared. So it's going to be it's going to be factored 2x plus 3y and 2x minus 3y. All right, just to be careful, this right here, you have to be extremely careful when you do this. Now, what I did here was, technically speaking, this is the correct answer for this. Technically speaking, whenever you square root something, the outcome is a positive or negative, because squaring something automatically gives you a positive result, but putting it back in, so for instance, 4x squared is always going to be greater than or equal to 0. Even if x is negative, it'll always be greater than or equal to 0. But initially, it could be that the x is negative, and although, hang on a minute. Right. We can't, by square rooting it, I'm automatically going to have a positive result. This is something I talked about yesterday. Whenever you square root something, you can't have a negative outcome, although it's possible that the original was negative. So it's quite possible that the x, so let's just say, let x be equal to negative 5, right? So 4 times negative 5 times negative 5. Okay, so that's going to be 100. Either way, it's still going to be positive. So the outcome is going to be positive, even if x is negative. Now, could it... We can't get an outcome where it's going to be 2 and negative 5. We can't do that because of square rooting it, we can't. So this goes back to what I was saying yesterday. I was saying about how you could technically say that, for instance, let me show you something. So this is the factored form, and let's multiply it out. 2x times 2x is going to be 4x squared, and then 2x minus 3y is going to be negative 6xy, and 3x times 2y is 6xy, and then 3y positive times 3y negative is negative 9y squared. These cancel, so it's 4x squared minus 9y squared, right? And that gets us back to the original form. However, let's do this. Let's, can we make the x's be negative? And yeah, we can, technically speaking. Now, the thing is, square rooting this thing, you can't have a negative outcome. But initially, I can still get the same result in a different way. Negative 2x plus 3y and negative 2x minus 3y will still give me the same result. So, and this is, again, if you watched my first video and I was a little wondering, like, why can we have a formula but the negatives isn't considered? And that's because on a square root in the reals, you cannot have a negative outcome. You can't square root and get a negative out of it. But technically speaking, there's two ways to get that. And that's is if the 2x were both negative. So let's do that real quick. So that's going to be, I'm just going to take this. Maybe I can't. All right. Let's just do it right here. Fine. Put it down here. So that's going to be 4x squared. And then negative 2x times negative 3y is plus 6xy. And then 3y times negative 2x is going to be negative 6xy. And then 3y times negative 3y is negative 9. Y squared comes out to 4x squared. These get scratched, minus 9y squared. So, here's the thing. There are two outcomes that can give us this form here. So, in other words, off of this form, I can't know which of the two it is, but we operate on the assumption that the x's are positive. We operate under this assumption right here, this formula. And the reason being is if we wanted to decompose it, we would have to use a square root. And the square root, we can't have a negative outcome. Basically, that's, I guess, I mean, I'm not a mathematician, okay? I'm a student. So that's my interpretation of why we use the formula, why. But technically speaking, if you did this, you would get the same result. That would also be equal to, that would give you the same result, just as a fact. All right, well, let's keep rolling along. But yeah, the answer I answered correctly, the greatest common factor. So, for the record, stick to the formulas in the book. If you don't fully understand it, like what I said, I went on a big tangent there. Stick to the formulas. And be extremely careful when square rooting something. How do you factor by grouping? 3, okay? Okay, factoring by grouping. All right, well, let's go back and see. Okay, here we go. To factor trinomial, okay, so that we're just going to write the formula. Ax squared plus bx plus c. We want to know what is the product of AC, and then we want to know the sum of b. So basically, and this is going to be, the sum of b is going to be, let's say, p plus q is equal to b, right? And then if we do that afterwards, then we factor out the greatest common factor of the entire equation. All right, don't worry if this doesn't make sense, but tell you what, since we're here, let's just do an example that we did yesterday. I'm going to say consider x squared plus 2x minus 15. Actually, is that going to be a greatest common factor? Yeah, that should do it. Okay, so we're going to say we want to know what is a times c. A is 1. And c is negative 15. 1 times x squared is the same thing as x squared, right? So that's why a is 1. So a times negative 15 is equal to negative 15. And we want to know what is p plus q is equal to b. So in this case, b is 2. Now, the p's and q's are taken from the factoring of our factor product of AC. So, in this case, we know what our A and C is. It's going to be 1 and 15. So let's go back here for a minute. All right, that's fine. Okay, so we have 1 and 15, right? And we need to get 2 out of it. Well, the closest to that right away, I'm thinking it's going to be 3 times 5. And what is B? B is positive. So then, but C is negative. So let's say if it is... Which one is it, though? Where does the negative go? Well, we want a positive b, so this smaller number will have to be negative. So we're going to say p, we're going to assign that to negative 3 plus 5 is equal to 2. Okay, so now we're going to expand this out by the formula. So we have... Okay, so here we go. And then we have ax squared plus px plus qx plus c. All right, so we have to take this formula. These are the steps. What is the product of AC? What is the sum of B using the factorings of A times C? And we did that. That was negative 3 and 5. And the sum of it would be 2. So P plus Q is equal to B. So negative 3 and 5 is equal to B. So now we just have this formula. And then we have factor the entire thing. So A is right here. And we have minus 1 x squared plus, what is our P? Negative 3x, negative 3x plus Q is 5x plus, what is C? Negative 15. Okay, so let's just simplify this, and then we're going to factor it afterwards. So we have negative x squared. We're going to say plus 2x minus 15. Did that get us back to where we started? Yes, it did. Hang on a minute. And pull out. Okay. Sorry. Before we go any further, we're going to pull out the greatest common factors between these. So we have the first part, this part right here, we're going to pull out the ax squared plus px. And then we're going to say factor. And then we're going to also factor of qx plus c. So the first part, well, we can pull a negative x out of it. So we're going to say negative x times x plus 3 plus, and then we're going to say here it's going to be 5. We're going to say x, and we pull the 5 out, so that's going to be, let's pull a negative. Let me think about this for a minute. That is not supposed to be negative. The 1 is not negative 1. It's just 1. I don't know why I made that negative to begin with. So we pull the x out. It's x minus 3. There we go. Minus 3. And then we pull the 5. It's also x minus 3. So the solution is going to be, we have x minus 3. And then we have x plus 5 times x plus 5. Okay, and just check that. Yep, that's what it is in the book. X minus 3 and x plus 5. So that's the final factoring of it. So these are the steps. We want to know the product of a times c. And this is the formula that we use for that. So we take our a, we take our c, we multiply them out. Then we factor the product of a times c, and we get p and q out of it. So again, they're not in the original formula. They're factoring of a times c, and then they should equal to b, the sum of them. And the b is a center one, so that's the 2 right here. After that, what we're going to do is we're going to write them in order like this, but we're not going to add them back together. Instead, we're going to factor them like this. We're going to factor this part, which is equivalent to ax squared plus px. And we're going to factor this part, which is equal to the qx plus c, right? And then afterwards, so then we combine the two. So they're the x plus 5, since they're being both multiplied by x minus 3. So see, there's an x plus 5. Both equations are multiplied by x minus 3. So that way I can throw a parenthesis about the two of them by pulling the x minus 3 out. Thus, we have completed the factoring. Anyway, that was a very long-winded explanation. But yeah, that's how it is done. In the book, it is factored by grouping, page 51, if you want to go check it out yourself. All right, let's keep rolling along. All right, so we have algebraic. For the following exercises, find the greatest common factor. Okay, what is the greatest common factor? All right, so we have now 5. So anytime you see a 49, think 7 times 7. mb squared minus 35m squared ba plus 77 ma squared. Okay, so I can definitely see we can pull a 7 out, right? Hope you see that right away. 77 is 7 times 11. 7 times 5 is 35, and 7 times 7 is 49. Should be able to see that. And the rest, we're just going to pull out, what do they all have in common? Well, they all have m's, and that's it. So let's do that real quick. So the greatest common factor, let's just start there, because this might be a multiple step process. We're just going to figure this out right now. So we're pulling 7 7, and then we're pulling an m out. 7m Hmm. 7m. We're going to pull that out for a second. Let's see what we have. We have b squared. We have 7b squared minus 5mba plus 11a squared. Okay, can we factor this further? Let's think about this for a minute. 7a times c gives us, so that's 77. Let's see if we can get a -5 out of 77. Probably not, because we can get a 4 out of it, 711. I think 77 could only be broken down into 7 times 11. And if we were to do a times b, that would be 7 times 11. Moreover, there's no m here that we can pull out. I think this is the complete factoring. Still, it feels like... What if it's going to be... Let's see. Yeah, it's the... and if we were to rewrite this in a different order, we could have probably done something if it wasn't for the center m. There's no way to do much with that, as far as I can see. So, I'm going to think that's the greatest common factor. Let's find out. All right. Oh yeah, that's fine. They didn't want us to factor the whole equation. They just wanted to know this part. The greatest common factor is just 7m. That's what they have in the book. So yeah, I did the whole thing, but really, they just wanted to know that part. What is the greatest common factor of those polynomials, or trinomial here? All right, let's go next one. That was 5. Let's go to 7. Same thing, we're just pulling out what do they all have in common. Do they all have m to the third power? Yes, they do. So we're going to say that. And then what is the smallest number they have? 30, but you can't... let's see here. Well, let's factor. So 200. What that's going to be 2 times 10 times 10. Right? 30 is going to be 3 times 10. We have 4 times 10 for 40. So we can pull a 10 out. That's the only thing that those three numbers have in common. Yeah, because the 4 and the 3, we can't do anything there. Okay. I'm going to say 10 m to the third power. And then we're just going to complete the equation. So that's going to be 20 p to the third power minus 3p squared plus 4. That looks right, I think. Let's find out. 7. Yep, 10m to the third power. They just want that. But yeah, so that's the answer right there. The greatest common factor. But I'm still going to factor the equation like that, so that's fine. All right, so now we have 6y to the fourth power minus 2y to the third power plus 3y squared minus y. Well, the coefficient, these coefficients, they don't have anything in common. I mean, technically, even if I were to pull a -1 out, it wouldn't really matter, because if I pull the -1 out, I would just have to convert everything to positive, except for this will become negative. So instead, we're just going to pull the y out. And there's smallest is 1, y. So we're going to say y times 6y to the third power minus 2y squared plus 3y minus 1. All right, let's check for that. Is y our greatest common factor? Yes, it is. That's the answer, the y. Okay, good. Now, factor by grouping. Let's want a clear page for that. Okay. So we have 11. We have 2a. Sorry, it's been a long day. Plus 9a minus 18. All right. So let's see here. So then I guess we're going to say we're going to have to break it down. So let's use it. We're going to say, what is a? And again, what is the coefficient to a? A is equal to 2. B is equal to 9. And C is equal to negative 18. What is a times C? 2 times negative 18 is equal to negative 36. And then we want to know that's a times C is equal to that. So, and now we want to know what is, we have factor negative 36 into P and Q, okay? And such that P plus Q is equal to B, which is equal to P plus Q is equal to 9. Okay? So what can we do? Well, 36, we have 6 times 6. That's not going to work it. 12, 24, 36. That's the one. Okay. So factor negative 36. So let's try negative 3 plus 12 is equal to negative 36. Sorry. Times, there we go. And negative 3 plus 12 is equal to 9. So we're going to say P is equal to negative 3. And Q is equal to 12. So now we have that. So now we're going to write this in the form A. Let me remember the form here real quick here. AX squared plus PX plus QX plus C. We want to write it in that form, and then we're just going to factor them like this. Okay, so let's do that. So we have, what is A? A is 2, so we have 2x squared plus PX is negative 3x plus 12x plus, what is C? Negative 18. Sure, that's fine. We're going to add it. Okay. So in that case, then we're going to factor, what can I pull out from this part here, right? What can I pull out from here? Well, we have just the x. We have x times 2x minus 3. What about on this side? Well, let's see here. Well, we can pull out, we have 12 and an 18. We can pull out a 6. So let's pull out a 6 plus 6 times 2x minus 3. So now, notice, the x plus 6 are both multiplied by the 2x minus 3. So that means we can take the x plus 6 and write them like this, x plus 6. Since they're both multiplied by 2x minus 3, we have that in the following parenthesis, and there we have it. The thing is factored. All right, let's check the book. This is, yeah. The only difference is that I wrote it in this form. Let's finish it up correctly, though. We had A's, not X's. So technically, it would be A plus 6 times 2A minus 3. Now, or I can do this. I'm going to say let X be equal to A. So by assigning that, then that fulfills that part of the equation. So that's fine too. The let part, normally unless you're writing like a proof or something like that, don't bother with that. Just put the A's instead of the X's. But by putting that there as a condition, technically what I wrote is correct. But I wouldn't go about it that way for this kind of thing. Just if it's asking in A's, you're right in A's. Okay? Okay, 13. So now we're going to do what is this? N's. 6n squared minus 19n minus 11. What is our form? Where we have, what is A, B, C? And this is our coefficients. 6, negative 19, negative 11. What is A, C? What is that equal to? That's going to be negative 66. And we're going to say factor AC into P and Q, and then find P plus Q is equal to B. All right, so these are two things we got to do. So we have what B is going to be negative 19. Oh, this is going to be a problem. I see. Well, 19 is a tricky one, so we really have to think about how we're going to factor 66. So it has to be, let me check my numbers one more time. We have 6 times 11, that's 66, and we need 19. P plus Q is equal to B, and this is factors of A and C, so fine. Well, 1 times 66 won't work. 2 times 33 won't work. 3 times 11, no, 3 times, that's the one. No, wait a minute. Yeah, it's 3 times 22. 3 times 22 is equal to 66. And we need negative 19, so we need to make one of them negative. So we're going to make the 22 negative. And that gives us negative 66, and then we're going to say P is going to be 3 plus negative 22 is equal to negative 19. Perfect. All right, so we have that. Now, we need the form. We're going to say AX squared plus PX plus QX plus C. So, now, the X is equal to n, okay? So in this, so we're going to fill that in. We're going to say ax squared is going to be 6n squared plus, what is our p? P is 3n plus minus q, which is 22n plus c, which is negative 11. So let's look at that again. We have 6n squared plus 3n. That's px, yes. And then minus 22n, which is our qx. And then minus c, which is 11. So just to be clear, everything is written out here. That's p, that's q. They are a factoring of a and c. A and c is 66, and we just factored it into 3 to 22, such that p plus q is equal to b. B is negative 19 right here. Okay, so hopefully that makes sense. Now, what can we factor here? Well, we can pull out a 3n, and that gives us 2n plus 1, and then we're going to say minus. What can we pull out here? Well, so we can pull out 11, or we can pull out a negative 11. It's even better. Negative 11. And if we do that, we're pulling out a negative 11 plus You know what? We're just going to go like this. Because it's the negative and that is next to it, we could think of it as being tied into it. So that's fine. So we're going to pull out, and that gives us 2n and then plus 1. Okay. So that way, if you look at it, look at that. We have the 2n plus 1 on both sides. So that means the 3n is multiplied by 2n plus 1, and the minus 11 is also multiplied by 2n plus 1. Well, if that's the case, then we can just put them together and then multiply them by the 2n plus 1, and there we have it. We have now completed the factoring. And again, it's written in terms of n. So, got that part. Let's check the book. 3n minus 11 and 2n plus 1. Perfect. All right. So far, so good. Let's do this. I am having fun. I hope you are too. All right. By the way, taking a quick break here. We're about like a third of the way through this section. I'll tell you one thing. If you're just watching this, like I'm doing this as someone who is studying mathematics to improve my own skills, to keep them sharp and so forth. I've passed this class, but the material, I don't perfectly have it memorized. So I do this for my own edification. I would highly recommend anyone interested in getting better at math to not just watch any videos, but you have to do the work. You have to physically do it, because if you just passively listen, your brain is not going to have perfect recollection. You're going to have gaps. And then if you're missing something important, you're going to get stuck, and then you won't know how to get past it. So that's why you have to do it. You have to be able to do these things. Anyways, let's roll on here. We have 2p squared minus 5p minus 17. So we have a is equal to 2, b is equal to negative 5, c is negative 7. What is ac? And that's going to be 2 times negative 7, which is negative 14. And then we're going to say factor AC, and then we're going to say such that into P and Q, such that P plus Q is equal to B. P plus Q should be equal to negative 5. Okay? So when we add them, so the bigger number is going to be negative. Well, whatever, they're factored already in a sense. We know a times c is going to be negative 14, and b is negative 5, so we're just going to say p is 2, q is negative 7, it's negative 5. So they've kind of given it to us, because in this case, normally it wouldn't happen this way, but the b matches to the factoring. So the outcome of the factoring, it made it easy to see right there. Anyway, so we have that. Now what we need is we have ax squared plus px plus qx plus c, and then going to say x is equal to n. So we're going to say 2, not x is equal to p. Oh, I shouldn't have done p and q here because we're writing in terms of p. How about PQR? Well, we're going to make it into R's, okay? We're going to say X is equal to R. So, yeah, that's because we're writing in terms of P, I didn't want to factor into P's. So anyway, just substituted that. So we have AX squared plus PX plus RX plus QX plus C, and X is equal to P. All right? So now we're going to say 2p squared plus, what is our r? And r right now is 2. So we're going to say 2. And what is our x is p minus 5 minus q. Sorry, the q is going to be negative 7. And x is equal to p. And plus c, which is negative 7. All right, so we have 2p squared plus 2p minus 7p minus 7. What can we pull out? First part, we can pull out 2p. and that is p plus 1. Yep. And then the second part, negative 7p minus 7. We're going to pull negative 7. And that's going to be p plus 1. Now look, we have the 2p is multiplied by p plus 1, and negative 7 is multiplied by p plus 1. So we can do this. We can go 2p minus 7 times p plus 1. All right, and it's written in terms of p, and we have factored. Let's find out. All right, p plus 1, 2p minus 7. Yep. All right, so far so good. I'm going to drink some coffee real quick, or some water, whatever I got here. Making all kinds of noise. All right, hopefully you're getting some of this. All right, so that's 15. Okay. 17. Factor the polynomial. We have 10h squared minus 9h minus 9. All right. So I guess we can again use the same factor by grouping. This looks like a factor by grouping. So let's just do that. So far it's been working out for us. Let's stick to it. We're going to say A, B, C is 10, B is negative 9, C is negative 9. Oh, okay. So then what is A times C? Is going to be negative 90. And now we want to know what is P plus Q is equal to negative 90. And we're going to factor negative 90 into negative 9. There we go. Into B. So P plus Q is equal to B. And factoring it into P plus Q such that P plus Q is equal to B. Okay. Into P and Q. Not P plus Q, into P and Q. Okay. Okay. Ooh. Well, what do we have? 30 times 3 is 90. About 15 times 6. That's probably it, isn't it? So it's 15 times 6. Yeah, that's the one. Okay. And we want negative 90, so it's negative 15. All right. So let's do that. We're going to say negative 15 plus 6 is equal to negative 9. And of course, 6 times 15 is 90. All right. It's real simple. 6 times 5 is 30. 6 times 10 is 60. Added together, get 90. So, yeah. All right. So we got that part done. So now we're going to write it as ax squared plus px plus qx plus c. X is equal to h. So we're going to say 10h squared plus, what is our p? Now, we're going to, I guess it doesn't really matter which is negative, but yeah, let's go with 15. It's fine. Negative 15. One thing I do, I like having a positive number first. So let's actually reassign them like this. So we're going to swap the two places. So it's going to be 6 minus 15 is equal to negative 9. So this is going to be P and this is going to be Q. Okay. And this is just like a convenience thing. Doesn't really matter. The numbers would still get the same result. So we're going to say plus, what is P? 6x minus qx, which is, sorry, not x, h, 6h minus 15h plus minus 9. All right, so then we have, well, we can pull out 2h times 5h plus 3. And then we can pull out my negative 3. And that gives us 5h plus 3. Yes. And notice that the 2h is multiplied by 5h plus 3, and the negative 3 is multiplied by 5h plus 3. So we get 2h minus 3 times 5h plus 3. So it's 2h minus 3 times 5h plus 3. Okay, let's take a look. Yep, so yeah, that's what they wrote. They just have the order the other way around, but it doesn't really matter whether one or the other. It's the same because you're multiplying. It's commutative. Anyway. Good. Well, you know what? We are just going to keep using this. We're going to probably beat this thing to death, but until they start giving us very simple forms or a difference of squares or something, we're just going to keep using a, yeah, we've been using this form. So yeah, factoring by grouping. So unless I see it, I'm like, that's a difference of squares. We're factoring by grouping all the way. 9d squared minus 73d plus 8. All right. So we have, what is A, B, C? Coefficients, 9, negative 73, and 8. So what is... Oh, that's a simple one. This is a real simple one. Okay. So we have AB, which is equal to 72, factor 72 into P and Q, such that P plus Q is equal to B. So P plus Q is equal to negative 73. So in that case, it's going to be 72 negative times, or plus 1 negative. That gets us negative 73. So as you can see, negative 72 times negative 1 is going to give us 72. And negative 72 plus negative 1 gives us negative 73. So that was like an easy one, right? They just gave that to us. Anyway, so let's do that. So now we have our P, we have our Q, we have our B. Now we're just going to write this AX squared plus PX plus QX plus C. All right, and then X is equal to D. So right here, this is our form, but we still have to write it in terms of the original variables. And the variable happens to be D that we're using. So A is 9, so we're going to say 9D squared plus, say, minus 72D. And then minus 1D plus 8. Okay. We're factoring out the 9D, and then that gives us 1 minus 8. 9D, yeah, that's 9. Wait a minute. There we go. That's D minus 8. So we factored out the 9D times D, that gives us 9D squared. And 9D times negative 8 gives us negative 72D. If we pull out the if we pull out, so here's the trick. In the next side, we're going to pull out a -1. And if we pull out a -1, that makes this a D, and the 8 becomes negative. And the reason being is -1 times D is -1D, and -1 times -8 gives us 8. Okay? So we did this, and now if you look at it, we have 9D times 9D minus 8 and -1 times D minus 8. So it's going to be 9D minus 1 times D minus 8. And there we have it. All right, let's take a look. This is number 19, I think. Yep. All right, book agrees. And yeah, was that 19? That was 19. Okay, so far so good. 21. Anytime it is a form that's not an obvious difference of squares, then or something like that, or if it's gonna be a squared plus 2ab minus b squared. All right, that's the difference of squares, whatever. But the point is, anything that we're doing, anytime we have an a for a coefficient that's not like 1, we're using our squares. We're using our factoring by grouping. So this is t, so we're going to say x is equal to t, and then we're going to say a, b, c. A is 12, t is 1, c is -13. We're going to say a times c is going to be 12 times -13. I need a calculator for this so I don't mess this up. And they're also giving us the answer already. It's 156. 156. And then we're going to say factor negative. As you can see, the answer is already written for up there for us. Factor negative 156 into P and Q such that P plus Q is equal to B, and that's going to be 13 minus 12 is equal to 1. All right? So again, as long as we multiply P and Q, 13, so P is going to be 13 and B is -12. We want a positive there, but we also want a negative here. This way we get both. So now we have our P, we have our Q. That's 12. And we just now have to do the form ax squared plus px plus qx plus c. All right, so we have 12. Remember, x is equal to t. So we have 12t squared. We're writing in terms of t. Plus, what is our p? P is 13. 13t minus 12t minus 13. All right? And in the first half of it, we can pull out what? We can pull out a t. That's about it. We have 12t plus 13. Let me write that a little better. It's just too messy. Plus 13. 12t plus 13. And in the second part here, we can pull out -1. That's 12t plus 13. And then we're going to finish the factoring. The t minus 1, both are multiplied by 12t plus 13. All right? And I don't even write the equation. This is 21. Yeah, it's 21. All right. Yeah, that's correct. All right. So here we go. All right. Moving along. 23. Difference of squares. It's 100. That's a difference of squares. You should see it right there. Difference of squares. A squared minus B squared, which is equal to A. So that's going to be A plus B, A minus B, right? A times A is A squared minus AB. B times A is AB minus B squared. Okay? So as we could see that gives us A squared minus B squared. So in that case, we're just going to square root this, assuming that the A is positive. Okay? We're going to let the A be positive. So if we square root 16x squared, be extremely careful when you do this. Technically, it should be plus minus for the outcome, but because we're square rooting a positive number, we can't have a negative number come out. So we're going to say 4 times 4 and x times x. So we're going to say it's going to be 4x, and square rooting 100 is equal to 10. All right, so that's going to be 4x squared, and then plus, it's 4x. So 4x plus 10 and 4x minus 10. All right. So 4x plus 10 and 4x minus 10. And again, if this is a square, we can just square root it to get A, and then we know what our A's are. And the B, one is going to be positive, one is going to be negative. All right, let's check that. It's 23. Yep, that's correct. All right, next. 25. That's a difference of squares. If there's two numbers, it's a difference of squares. So that's going to be 11p plus 13, 11p minus 13. All right? Okay, that's the answer. Okay, yep, that's the one. Now, how did I know that right away? I happen to know from my own memory that 11 squared is equal to 121. I just know that, okay? I also know that 12 squared is equal to 144. I also know that 13 squared is 169, right? Those things, you do enough numbers, you're going to know them. You're just going to know them, that those are the squares of those numbers. Just as you know that 10 times 10 is 100, right? Or 10 squared is 100. So I happen to know that, so right away, I instantly saw the 121 as 11 squared, and the p is obviously squared, and I saw the 169 as 13 squared. I didn't even have to do anything. I simply knew the answer and just wrote it down. That's it. But I had to demonstrate this to you, that you weren't thinking that I was just like pulling it from the back of the book or whatever. Anyway, let's keep rolling along. All right, so 27 is 361. I believe that's 19 squared minus 81. Something's not right. I can't seem to hit back. Let me try new. Don't save. Okay. Let's say this. So this is 1.5. And we're going to say 361 d squared minus 81. 361, I believe that's 19 squared. Let me check that. 19 times 19. Yeah, that's 361. Because 20 squared is equal to 400. 19 squared is 361. Okay? So, in that case, so we know that it's going to be 19d, and then it's going to be plus 9, 19d minus 9, because 81 is 9 squared. And we're using our difference of squares formula, which is a squared minus b squared is equal to a plus b, a minus b. That's difference of squares. And all I did was I square rooted from memory the 361 in my head, and of course the 81, we should all know that by now. Okay. But for the sake of the book, let's check it real quick. 27. All right. Yeah. Yep. Everything's good. All right. Keep rolling along. All right. so 29. Okay, that's 12 squared. And this is 5 squared. So this is going to be 12b. I don't know what's going on here. Okay, there we go. So we're going to say 12b plus 5c. And we're going to say 12b minus 5c. You should be able to see that. Just as I mentioned a couple minutes ago, 12 squared is 144, and b squared is b. So, and of course, we have the 5c is if you square that, that's 25c squared. So yeah, that should be the answer there for 29. Yep, that's the one. All right, let's keep rolling along here. Okay, 31. So we have 49 and squared plus 160. I wonder why I can't seem to do back on this pen. I'm just trying to figure out what's going on here with my menu. Okay, I need to make sure. Maybe that's what the issue is. I have to plug in my laptop. Give me 1 second. It's been acting up. All right, let me see now if I can do a reverse. Let me try and X this out, because yeah, my software is not responsive. Okay. Let's restart everything here. Okay. Let's paint. Okay. Okay, now it's responsive. I don't know why it does that. Sometimes, I don't know, maybe I write too fast, but it just crashes. That shouldn't have any kind of impact on it. Honestly, I don't know why. Maybe because my laptop was running slow and it sent me an alert and there was a crash in the interacting of the systems. There could have been a drop off. I don't know. Whatever. Let's just work on 31. 49n squared plus 168n plus 144. Okay. So, yeah. Right. So we are going to do a difference of squares. Not different squares. I mean, we're going to do our, grouping. We're going to do the, I keep forgetting the term, factoring by grouping. Yeah. So we're going to say A, B, C. We're going to say X is equal to N. And A is 49, B is 168, and C is 144. And we're going to say 49 times, 49 times 144, and we want 168. Okay, that's going to be a hard one to factor. Times 49, that's 7056, and we need it such that it's going to give us 168. 168. I wonder if it's going to be something like... All right, well, let's see here. Well, let's try it. Let's see what we can factor it into. So this is equal to 7056. So this is what you can do. 7056. We're just going to break this down completely. We're going to factor 7056. Let's see here. Divide this by 3. So that's 3 times divided by 3. 3 divided by 3. Nope. 84 divided by 2. Times 2 divided by 2 times 2 divided by 2 times 2 divided by 2 times 2 times 7 times 7. Okay, and we'll just multiply all this out. So that's 9 times 7 times 8 times 2. I must have missed something. So, okay, let me check this one more time. Oh, I got a, let me try again. Okay, let's try it one more time. So we have 7056 divided by 3, yes, divided by 3, yes, divided by 7, divided by 7, divided by 2 times 2 times 2 times 2. Oh, yeah, okay, so that should be fine. Let me try this. Oh, that's what I missed it. It's 7 times 7 times 9 times 8 times 2. There we go. Okay, so that's fine. So I've completely broken it down. And then we just have to, let's see what numbers we could assemble such that together added, they're going to be 168. So 72. All right, so it's just that now I have to figure out how to best assemble this. All right, so what we want to do is, well, what can we multiply them? So if we go, let's try 7 times 7, that's 49. So we're going to say this is 49. And 3 times 3, this is 9. Let's multiply those by 9. So it's 4 and 11. And then it's, no, that's too big. So let's try 16 times 9. It's 144 plus 49. It's 193. So what then if we take, let's try, we're going to have to swap the 3's and the 2's somewhere, I think. Or maybe it's going to be 3 times 3 times 7. 7. So that's 63 times 3 times 7. And that leaves us 7 times 16 times 16. It's 112. 112. So that's 63. No. I gotta think about this for a minute. Let me look at this one more time, make sure I didn't screw up the writing of this. 49n squared plus 168n plus 144. Okay, so let me think here. Let's see here. We need to factor 7056 such that we get 168. What two numbers can we combine to get 168? But it was close to 3, 3. How about 2, 3, and 7? 2 times 3 times 7 is 42. So we have, so that leaves us with 3 times 8 times 7. 3 times 8 times 7. That's 168. This is a tricky one. That's the problem. Factoring large numbers is hard like this. All right, let me think about this for a minute here. What about 7 times 8? 7 times 8 is 56. And then we're going to have 9 times 2 times 7. That's 126. Together, that's too much. That's 182. But it's close. And that was 7 times 8. How about 7 times 9? Did we try that? Let's see here. What can we get? 7 times. So we tried 7 times 7, which is 49. And then the rest is going to be 9 times 16. That's 144. It's like 200. So 7 times 7 doesn't work. If we went lower, 7 times 6, that's 42. And then the rest is going to be 7 times 3 times 8. That's 168. That's even bigger. So 7 times 7. Then let's try 7 times 8. That's 56. 7 times 8. So that gives us 7 times 9 times 2. That's 126. That's closer. That's 181. How about, can we get 7 times 10 or 7 times 11? What can we get here? So we have, we tried 7 times 9. How about 7 times, so we have 3 times 2 is 6, times 2 is 4, or 2 times 2 times 2 is 8. So let's try that. Let's try 7 times 12. Times 12 is 84. So 7 times 2 times 3 is 84. And then we're going to try, so that gives us 7 times 2 times 3. That also gives us 7 times 8 times 3. Really? What? 7 times 2. Oh, that's 6 times 2. There we go. That's 12. 7 times 12 is 84. All right. So then we're going to have 2 2s are gone. Is that exactly 84? That's it. That's the one. That is the one. Perfect. Okay. 7 times 2 times 3 times 2. Look at that. Look at that. 7. There's 2 of them, right? There's 4 2s and 2 3s. So it's literally right down the middle. Oh, I should have tried that to begin with. But notice how I solved it, right? Factoring a big number is hard. But I knew that I wanted to get a feel for which number. I knew 7 times 7 is 49, and then the rest is 168. And if we add them up, it's like, that's over 200, right? 7 times 6 is even bigger when we add them together. So I started going the other way. 7 times 8, it was under 200 when you add it together with the rest. And then I was like, okay, well, 7 times 9, close, but not quite. And then I was like, what about 7 times 10? Can't do that. Can't get a 10 out of these. What about 7 times 11? Can't get an 11. What about 7 times 12? And that was it. And that's how you solve it, you know? Anyway, so we have that. So P plus Q is equal to B. So 84. What do we want for B? Positive? 84 plus 84 is equal to 168. Okay, we have it. We're back in business. So we're going to say ax squared plus px plus qx plus c. X is n. So we're going to say 49n squared plus 84n plus 84n plus 144. And now, in the first part, we have 49. What is that, like 7 times 12 is 84, yeah? 7 times 12 is 84. So we can pull a 7, and we can pull an n out, and that gives us 7n plus 12 in the first part. In the second part, we have 84n plus 144. Well, in that case, we can just pull the 7 out. No, we can pull a 12 out. Plus 12 times 7n plus 12. Okay? So now we have 7n times 7n plus 12 and 12 times 7n plus 12. So both the 7n and the 12 are multiplied by 7n. So that comes out to 7n plus 12 times 7n plus 12. And we have it. We have it. All right. Okay, that was some work. But hopefully you see how this works, right? And just to prove it, 7n times 7n is 49n squared. 7n times 12, and then going to be plus, that's 84n. 12 times 7n is 84n, and 12 times 12 is 144. So there we go. That's going to be 49n squared plus 168n plus 144. Okay, so there. But for the sake of consistency, let's check the back of the book. And yeah, that's 7n plus 12 squared. So you could also write it like this. 7n plus 12 squared. Now, that's a perfect square. Maybe, see, like, I solved this using the grouping by squares. Let's take a look at the perfect squares formula. That's probably what I should have done. Okay. So, let's see here. Yeah, no. Okay, so in this case, I'm just looking at what formulas could we have used to help us solve this faster. Perfect square trinomials. Here we go. We could have tried a squared plus 2ab plus b squared. So if we were to try this, we're going to try this one more time. Let's try this a squared plus 2ab plus b squared. So if we were to do this, and if we were to take that formula, we could have square rooted this, and we could have gotten 7n. And this we could have square rooted, and we would have gotten 12, and 7n plus 12, and we could have squared that, and we would have been done. So either way could have worked. Now I went about squares grouping because I don't know, brain freeze or whatever. I didn't see it just by staring at it right there, but that was basically a perfect squares situation. So yeah, that's a simpler way to go about it. To know that this actually works, you have to multiply 2 times 7n times 12, which is equal to 80. 12 is going to be, so that's going to be 24 times 7n, which is 168. So, because 7 times 4 is 28, and 7 times 2 is 14, plus 2 is 16, so it's 168n. So that's how you would have proven that. However, the grouping by squares is very powerful. Even though it took me longer, it demonstrates just how powerful it is. That even if you don't off the top of your head know or see the perfect square in it, you can still get your way there. And that's really something that, you could check just by dividing the numbers in half, a 7 on each side and, 3 on each side and so forth. So, and then multiply it out. Okay, well, let's continue here. All right. All right. What was that? That was, let's see here. That was 31. All right. Well, that one caught me off guard, but I don't think I'm going to let the next one catch me off guard. Let's take a look at 33. 225y squared. We're going to see if this is perfect squares. Looks like a perfect squares. So we're going to say 225y squared, square root that. That's going to give us 25y. 16 square rooted is 4. So let's try a squared plus 2ab plus b squared. So let's try that. We're going to try 25y squared. What is that? Plus 2 times a, which is 25y times 4 plus 4 squared. So 25 times 25. Wait, is it 15 times 15? I think actually 25. Wait, I'm doing this wrong. 15 times 15, it's 225. So check it. Yeah, it's 15 times 15, not 20. This is why you have to check your work, but it's this was fine. Which is, it's right here that it's different. Yeah, because I thought the numbers got a little big there. Okay, so primarily, 15 times 15 is 225 and y squared. That's 225y squared. Then we have 4 times, let's do it this way. 15 times 2 is 30, times 4 is 120. And then we have y plus 16, and that gives us the original equation. So we know that this, and we know what our a is. So this is equal to a squared plus b squared. All right. In that case, we know that it's 15y squared. Actually, no, that's incorrect. That's the wrong formula. It's a squared, a plus b squared. Yeah. So a squared plus b squared is equal to a times a, and then a times b, and then b times a, which is also a times b, and then b times b. So that's correct. That's the one. You cannot factor a squared plus b squared. That is already factored. There's nothing further you can do with that one. The difference one, the a squared minus b squared, you can factor, but not the positive. So we know what our a is. A is equal to 15y, and b is equal to 4. So let's just write the answer, 15y plus 4 squared. All right, let's check that. 33. 51, yep, that's the one. All right, keep going. All right. 35. We have 25p squared minus 120p plus 144. So, that looks like a difference of squares. Looks like an a minus b squared. Because, well, let's just square root these and see what we get. 25p squared square root is equal to 5p. 144 square root is equal to 12. But we need the negative here. So let's try 5p minus 12. And then we're going to say, actually, we're going to say this. Hold on. I believe that's... I mean, here, hold on. No, something's not right. It's difference of squares. So 5p plus 12 times 5p minus 12. So that's the difference of squares formula. So, and if you multiply that out, we're going to say 25p squared, and then minus 60p. 12 times 5 is 60p. And then we're going to say minus 144. Although, that's the only thing is, we need the negative 120p. So it's just going to be, it's 5p minus 12 squared. There we go. So this one right here would have been a difference of squares, and that would have been 5p squared minus 144. We don't want that. We want to have the 120. So that means we want 5p minus 12 times 5p minus 12. So that's 25p squared minus 60p. That's 5p times 12. 12 times 5p is another 60p negative. And then negative 12 times 12 is 144. So we have 25p squared minus 120p plus 144. So this is our answer right here. And we could just merge it together, and it's going to be 5p minus 12 squared. All right. That's the one. All right, keep going. All right, and so we got the 35. For the following exercises, factor the polynomials. This is a trinomial. We have x to the third power plus 216. So we want to know what is the cube root of 216. That's basically it. What we want to know. So let's try. So cube root of x is going to be just x, and the cube root of 216. So we're going to take 216 divided by 2 is 108. So cube root, so it's going to be 2 times divided by 2 is 54 divided by 2. That's times 3 times 3 times 3. Okay, so that's going to be, is that right? No, it's times 2. There we go. Because it's times, so it's going to be 2 times 2 times 2, which is 8 times 27. That's 216. So if we're cube rooting it, we are getting 1, 2, 3. We get 3. Scratch the 2's. We get a 2 back. We get 6. So it's going to be 6 x times 6x plus 6 cube root. That cube root to the third power. So x plus 6 to the third power. And if we were to multiply this out, this should be it, but let me check something here. Because the only thing is that those are the numbers if we broke them down, but there is a slight problem. Multiplying it out might not get us the number we want. It might have to be x minus 6 isn't going to do it. Let me try this. So if that's what to the third power is, but let's try it real quick. So we have just the first two parts. I'll just do 2 parts, and then I'm going to show you we're going to have some issues. So that's going to be x squared plus 12x plus 36. So this is the problem, the middle part. Let me check how we're going to factor trinomials. The numbers that we have, though, the x plus 6, are definitely it, but I have to finish doing that part. Oh, right. Okay, so if we have the trinomial, so we're going to say that's the rule. So we're going to say a plus b to the third power is equal to same and then we're going to be a squared different, ab always positive, b squared. That's the form you want to use. All right, so in that case, we're going to go with x plus 6, and then we're going to be x squared minus 6x plus 36. Okay? All right, that's the form we got to take. And let's check that real quick. So we have x to the third power minus 6x squared plus 36x. And then we're going to say plus 6x squared and minus 36x plus 216. All right, and then we're just going to scratch. We have x to the third power plus 216. All right, so we have it. We have it. It is this form right here. All right, let's check that. All right, that was 37. Let's check it. 37. X plus, yep. All right, yep, that's it. That's the one. All right. 37 is done. Now we have 39. We have 125a cube root plus 343. All right. Well, let's see what we have. We're going to say a cubed plus b cubed is equal to a plus b. So the same sign. And then we're going to say a squared different to ab, different sign. And then always positive for the last sign. Okay, that's the rule. So if we're going to take, so the cube root of 125a to the third power gives us 5a. So at least we know that one. That's a simple one. So we have 5a plus, what is 343? That's like probably 49 times 7 or something. That's the one. Okay, so 7 times 7 times 7 is equal to 49 times 7, which is equal to 343. That's another one I just had in the back of my head. So cube rooting 343 gives us 7, if it's a cube root. So now we have a plus 5a plus 7 with a squared. That's 25a squared. So 5 squared, 5 also gets squared. Minus 2 times, we're going to say 5. I'm just going to write this out first. Times 7 plus 49. Okay. So we're going to say 5a plus 7, 25a squared, minus 70a plus 49. All right, let's just check that, because negative 2 times 5 is negative 10, times 7 is negative 70. It looks right to me. Let's check it. 39. Okay, 5a plus 7. Wait a minute. It's negative 35, not 70a. Hang on a minute. Is that a misprint? I don't think it's a misprint. My mistake somewhere. Hold up. Oh, okay. That's where I messed up. It's AB, not 2AB. This 2 was not necessary. So that, I messed up the formula. Bold of me to assume it was a misprint, am I right? But there we go. So 25a squared minus 35a plus 49. That's the correct form. Okay, that was 39. And now, continuing on, 41. 41. 64x to the third power minus 125. Okay, cube root of 64x to the third power. So that's going to be 4x. And cube root of 125 is 5. So because 4 times 4 is 16, times 4 is 64, and cube rooting x gives us x back. Okay, so we have our form a cubed plus or minus b cubed. That's equal to the form of a minus b, same sign. And then we're going to say a squared, different sign, ab, always positive for the last sign. Or it doesn't matter. This is always positive, the last sign. And that's b squared. So that's our form. And we just have to populate them. A is equal to 4x. B is equal to 5. So we're going to say 4x minus 5 times 16x squared plus 20x plus 25. All right, let's check my numbers real quick. 4x minus 5. It's 16x squared. 20x plus 25. Looks right to me. Let's check it. 41. 4x minus 5. 16x squared plus 20x plus 25. Yep, that's the one. All right. So far, so good. Next, we have 43. All right. For 43, we have 125 r to the third power plus 1728 s to the third power. So that's 125 r to the third power. If you cube root that, that's going to be 5r. 1728, 5, that's s to the third power. I have a feeling that's probably 12 to the cube root. Let's try 12 times 12 times 12. That's the one. Okay, so that's going to be 12s if we cube root that, s. So we have a plus b is a cubed plus b cubed is equal to, decompose, it's a same sign, plus b, and then we have a squared, different sign, plus ab, always positive. Okay? And then we're just going to fill them in. A is equal to 5r. B is equal to 12s. Okay? So let's populate them in. We're going to say 5r plus 12s. And then 5r squared is going to be 25r. Sorry, 5r squared gives us 25r squared. So the whole 5r is being squared, basically. Minus 5r times 12, so that's minus 60rs plus 12s squared gives us 144s squared. Okay? All right, let's take a look real quick. And this was 43. Okay, 5r plus 12s, 25r squared minus 60rs plus 144s squared. Yep, that's the one. All right, good. And 45, we have 3c times 2c plus 3 to the negative 1/4 minus 5 times 2c plus 3 to the 3/4. Okay, so what we need to do is we need to establish both that have the smaller of the signs. So we want to do is we're going to have this, let me here for a second here. So it's going to be 5 times. I have to go back and look at the form real quick. We did a bunch of these yesterday, but I wanted to review it real quick. Right, okay, so we're going to pull out the factor. If I pull out the factor of... Okay, so I want to end up with this form. So if I was to pull that out, so let's say this. We want to know what this one is. We want to know, let's see here, y minus 1/4 is equal to 3/4. That's what we want to know. We want to know what the power is if we were to take this 1/4 power out, right? We want to have a negative 1/4. Well, if we take it off from y, that gives us negative 3/4 because we have to rewrite the equation with 2c plus 3 to the power of y. What is that? Well, the way to do it, we're just going to add it, the 1/4. So we're going to add it. Just to remember, just for your memory's sake, so x, you have something like this, x to the power of let's say x to the a, and then you're also multiplying it out to the x to the b. The result, they're not multiplying. The x's becomes, the powers get added. So it's a plus b. Anytime you have a multiplication of x to the a times x to the b, the x's merge and it becomes x to the a plus b, basically. So that's what we're doing. We're doing addition up there. All right, so the result, of course, is going to be y is equal to 4/4 or 1. So let's rewrite this whole thing. All right, we're going to say 3c times 2c plus 3 to the negative quarter. And then we're going to say negative 5 times 2c plus 3 to the first power times 2c plus 3 to the negative 1/4 power. Now, the first power is the same thing as saying to the 4/4 power. And if we merge them, we're going to end up with this, okay? So that's what you have to understand what's happening here. It might be a little confusion, but remember the x to the a times x to the b is really to the x to the a plus b, okay? So in this case, what we end up then with is this. We're going to rewrite this again. We're going to have 3c with the 2c plus 3 to the negative 1/4 minus 5. Now, the 4/4 is to the power of 1, and we can just drop that because x to the power of 1 is the same thing as x. And just as x to the 4/4 is equal to the 1, which is equal to the 1, which is equal to x. This is all the same. All right, so we're going to say 2c plus 3, and then we're going to say to the 2c plus 3 to the negative 1/4 power. All right, so then what we now have is yeah, almost done with this. Now, the way I'm going to merge this is like this. We're going to take this, and that's going to be our outer thing. So that's going to be the last, and we're going to multiply. Since all of these elements are being multiplied by that, we're going to put them all together into the same parenthesis. So we're going to have 3c minus 5 times 2c plus 3. So they're all in the same parenthesis now. And then times 2c plus 3 to the negative 1/4. Okay? So now we just have to simplify. We're almost there. So we have 3c minus 10c minus 15. As long as the math doesn't get mixed up, we should be fine. All right, and then so we're going to drop this and make that a negative 7c minus 15. And then we're going to add the 2c plus 3 to the negative 1/4. So now that should be it. That should be the factored form of it. And that was 45. Yep, that's the one. Now, of course, remember, it doesn't matter what comes first. You could write the 2c plus 3 to the negative 1/4 times negative c minus 15. The parentheses, they could be switched around. That could be there. This could be here. It don't matter. Multiplication is commutative. All right. And just 1 second here. Yeah, and the multiplication is commutative. You should know that because a times b in multiplication is b times a. So that's what it means by commutative. Make sure I spell that right. Commutative. A times b is equal to b times a. All right. And we now go to 47. Here we go. All right. We have 14x times x plus 2 to the negative 2/5 plus 5 times x plus 2 to the 3/5. So again, we have y and minus 2/5, and that's going to result in 3/5 plus 2/5 plus 2/5, which is equal to 5/5, which is equal to y is equal to 1. So that's it's just convenient. They're giving us really simple forms here, very, very simple forms. Okay, there we go. Too far here. There we go. Okay. So now we're going to go like this. We're going to say 14x times x plus 2 to the negative 2/5 plus 5 times x plus 2 to the first power times, well, let's just write it as 5/5 times times x plus 2 to the negative 2/5. So the 5/5 plus the 2/5 gives us a 3/5. Hope you see that. All right. All right. So now we're just gonna merge. I'm going to say 14x plus 5, and 5/5 is equal to 1, by the way. So we're going to say 5 times x plus 2 to the 1. And we're going to throw a parenthesis on these. And then x plus 2 to the negative 2/5. Okay. So the 5x plus 2 to the 1, That's just the same thing as x plus 2. So now, let's continue simplifying. 14x plus 5x plus 10 times x plus 2 to the negative 2/5. And that comes out to 19x plus 10 times x plus 2 to the negative 2/5. All right. $47. Now, they have a preference to x plus 2 to the negative 2/5. To write it this way, it doesn't matter. Multiplication is commutative. Either way is fine. These two are the same. So, all right, and now we have 49 5z times 2z minus 9 negative 3/2 plus 11 2z minus 9 minus 1/2. Okay, so which of the numbers is smaller? So let me think here for a second here. Okay. All right. So we want a positive number, preferably here. So the so y minus, let's see here, y minus, let's try them both. My brain's not working right now. 3/2 plus 1/2 plus 1/2, which is equal to y minus 1. All right. Y minus 3/2 is equal to 1/2 plus 3/2 plus, this is negative 1/2, plus 3/2 is equal to y is equal to 2/2, which is equal to 1. So that's the one we want. Y minus 3/2. So let me think this for a second here. Right. So we're going to say 5z times 2z minus 9 to the we're just going to say 2 times 2z minus 9 to the negative 3/2. Wait a minute, it's not what we want. Let me think here. So we have to perform an addition. Oh no, that is what we want. That is exactly what we want. But our result should be 1/2, and we're getting negative 3/2. In other words, in other words, this is what they want. They want something like this. They want 5z with the 2z minus 9 to the negative 3, 2 plus 11 times 2z minus 9 to the negative 2, 2. And then we're going to say times 2z minus 9 to the, oh, right, to the 3, 2. That's where it is. This is positive because, okay, that's the one we wanted. Yeah. I was trying to pull out a positive number because then I can make that fraction, that power disappear. As long as it's a whole number, I'm going to make it disappear. So that's good because if we take the negative 3, 2, and we're going to add 2, 2 to it, we have negative 1/2, which is where we came back to it. So we have decomposed it properly. And now we're going to rewrite this. So this is equal to 5z times 2z minus 9 to the negative 3, 2 plus 11 times 2z minus 9 to the first times 2z minus 9 to the negative 3, 2. Okay, and now we're going to make a merging now. We're going to say the 5z plus 11 times the 2z minus 9, and put them all in the parentheses, times 2z minus 9 to the negative 3, 2. So basically, we grouped this and this here, and this here, like that. Okay, I hope that makes sense. And the reason we're able to do this, just like we've been doing this whole session, is that whenever you have two numbers, let's say ax plus bx, you could always do this. Pull the x out and make a plus b, like this. So, and basically that's what we're doing there. And that's distributive property. All right. So now we're just going to finish this. We're going to say 5z plus 22z minus 99 is equal to, or no, not equal, times 2z minus 9, negative 3, 2. And then we're going to finish this by saying 27z minus 99 times 2z minus 9 to the negative 3, 2. Okay. All right, so let me just check that. 5z plus 22z is 27z. And then yeah, we have was 9 times 11. So yeah, that's should be negative 99. And then we have the 2z minus 9 to the negative 3, 2. All right, let's check it. Okay. 49. 2z minus 9, negative 3, 2 is 27z minus 9. Yep, that's the one. All right. Great. All right, so we're about the 2-hour mark. We just finished page 56 So we still have one more page of equations left. And I will take a break. I'll either do that tonight or maybe I'll stream calculus. But yeah, we'll definitely get those done by tomorrow. Then we're going to go into 1.6. And I'm just looking at this thing here. Yeah, and then we have 1.6 is the last in the chapter 1 sections. After that, we have review exercises, a practice test, and that is going to take us to chapter 2. All right, so really cool. Anyways, I hope you're having fun. I know I am. All right, this is the end of 1.5-2, and join me either later tonight or tomorrow for 1.5-3 and then into 1.6. All right, see you next time.